All right, so now we're going to talk about histograms. Histograms is that graphical display of frequency distributions that we just took a look at, right? So we'll create these tally marks and these frequencies and these relative frequencies, and then we're going to want to come up with a graphical display, right? And again, graphs are just our way of looking at the data in an overall sort of picture format and get a sense of what the data is trying to say in an overall sense, instead of having to look at each individual data piece, okay? So what is a histogram? A histogram is a bar graph, basically, and I'm sure you've seen bar graphs before. But it's a bar graph that represents the frequency distribution of a data set. So a histogram has the following properties. It has a horizontal scale that's quantitative, right? It's going to be basically our intervals that we created before from our frequency distributions. And it's going to measure the data points, right? The vertical scale measures the frequencies of those classes. So we'll create classes or intervals like we did before, and we might do it a little bit differently with histograms. And then, unlike bar graphs that you've seen before, histograms, the bars need to touch. They're going to be side by side, right? And the reason why is when you start talking about numerical data, quantitative data, very often that data set is continuous. We'll talk about that in a little bit at a later time as well. But what that basically means is data points can fall in a lot of different areas and not just like whole numbers, right? So, for example, if you were going to go shopping for a new iPhone, right? iPhone 11 might run you, I'm making this up off the top of my head, like $625.99, right? Whereas the iPhone 10 or the iPhone X or whatever you want to call it might be, $435.27, depending on where you go. So they're not going to be whole numbers, and so you don't want to create gaps in your histogram. A gap's going to represent zero data points sitting in a particular interval of prices, right? And so we don't want to create spaces in between our bars, all right? Unless there are no data pieces in that particular interval, then you'll have a gap or a space, right? So we're going to try to create histograms to where all the bars are touching. Here are some examples of histograms, right? So here's a histogram. There are bars, but they're not separated by any space. So this first bar represents innings, right? So this is Markham fastball speed, right? And so in this range of innings, so 80 to 81, there's a percentage of times that this baseball pitcher did something. It's kind of hard to tell exactly the details in this particular histogram, right? Let's get to a better one. Here's a good one. It talks about hours slept each night, right? So our horizontal axis is a numerical representation, but it is a representation of an interval, right? Here, it's just each bar represents a particular number of hours of sleep. 5, 6, 7, 8, 9, 10, 11, 12. But the range or the class might have a different set of values. So this class might span from, say, 4.5 to 5.5, right? But 5 would be that mark or that midpoint of the interval that we're going to use to actually represent the graph. So anyway, this graph lets us know that one particular person got 5 hours of sleep, one particular person in this sample got 5 hours of sleep, 2 people, right, got 6 hours, 4 people got 7 hours, 3 people got 8, 3 people got 9 hours, 3 people got 10, 2 people got 11, and 2 people got 12 hours of sleep, okay, each night. But that's basically what they're showing us. Here's one that's minutes spent on the computer. So our our minutes have been broken up into intervals, and there's a bunch here, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? That's a lot of intervals. It's definitely more than what we usually want to have. And your data is so spread out that you can't get a sense of what it really looks like. And again, we'll talk about later shape and range and things like that. So anyway, but just another minutes intervals across the bottom, and then how often we get a data point that falls in that range. So 3 people spend 0 to 5 minutes on the computer, that kind of thing, right? And here's the last one about average SAT math score. This is definitely more computer generated, where the horizontal axis isn't quite as detailed. But still, you can kind of get a sense of what's going on with just the limited amount of detail in the horizontal axis, right? But that's basically what histograms look like. So let's talk about creating a frequency histogram. So it's kind of like before, where we're going to want to come up with our classes. Classes are kind of like intervals from our table before. The classes can be defined by really by however you want it to be. As long as they all have the same width, that's important, right? The classes can start at any numerical value and end at any numerical value as long as it spans across all of your data. And then they can be as wide or as thin as you want them to be. It really depends on how many bars you want to look at, how many classes, how many intervals do you want to look at, okay? Going back to the text message data from the previous video, we've created sort of a different number and a different set of intervals, right? Before, our intervals started at 8, the smallest value in our data set, and then we started creating our intervals from there. Here, it kind of started to make sense to come up with the number of intervals that we want, and then kind of set this width from there. So 1, 2, 3, 4, 5, 6, 7, 8. So apparently this table wanted 8 classes, and because our highest number of text messages was 400, go ahead and divide 400 by 8 and you get 50. So that kind of was one way to come up with our class width, which is 50 text messages here, okay? So how many fell between 1 and 50? We've got new tally marks. You can see how the tally marks changed once we've changed the width of our classes or our intervals, right? And again, what may happen is you type all of your data points into a list, into a program, and you ask it to spit out a histogram, and it may create so many bars that you really can't see what's going on or get any kind of sense of the data. And so you might need to go in and readjust the width of those classes to kind of give you a better sense of what the data looks like. So it's kind of arbitrary as long as you get characteristics out of the graph that you want. So with these sort of new classes that have been defined, we have the tally marks there and the frequencies with which we find these data pieces occurring. Now, if you notice in our intervals here, there is a gap between 50 and 51, 100 and 101, and we don't want that, right? We want to cover, I mean, obviously you can't send half, well, we'll get to that. It makes sense to have these intervals because you can't have an interval share 50 text messages. So to separate the intervals by a text message makes a little bit of sense, but we don't want any gaps. We want all of our bars to touch. So what we do is we might subtract, say, half of a half from the lowest end and add a half to the highest end of each of our intervals so that we can get our bars to touch. So in other words, from 1 to 50, if I subtract a half from 1, we'll get 0.5. And if I add a half to 50, then we might get 50.5, right? And then if I do the same thing here, if I subtract a half from 51, we'll get 50.5. So now our classes are going to share, right, a number, and then we're going to add a half to the other end, and so on and so forth, and that'll get our bars to touch. Now, obviously, we can't send half a text, so you're not going to have any data points actually fall on 50 and a half. But that's our way of knowing which interval our data piece will fall in, but still get our bars to touch. And so if we continue on doing that same process, we get all of our class boundaries that look like this. Okay. Now your graphing calculator and different computer programs will do this for you already. And then we can, again, we'll take a look at readjusting those as we need to. Okay, but for here, we created our intervals, and then we adjusted the upper end and lower end so that all of our bars would touch, all of our intervals would touch, without being confused as to where each data piece might fall, which data interval our data pieces might fall. Okay, by adding or subtracting a half to the upper and lower end. Okay, now that we have our class boundaries, we're going to want to create our graph. So a vertical and horizontal axis. Again, the horizontal axis should contain our numerical data. So our number of text messages is going to be on the horizontal axis, and then just the frequency is going to be on the vertical axis, right? Frequency in which these intervals, data pieces fall in these intervals, right? Always label your axes and label your graph so that everyone can see what the data is supposed to represent. Okay, so we're going to label our horizontal axis with our lower and upper boundaries for our intervals, for our classes, after we've added and subtracted the half to either end, and so you can see the horizontal axis listed there, right? And so these are our text message intervals. And then one thing to point out is our histograms don't have to start at 0 on the horizontal axis. Sometimes our data pieces will have values so large that in order to look at the graphical display, we've got to move all the way over to the right on the horizontal axis, and so it won't start at 0. So what you have to do is include that little symbol down there, that little squiggly, to let you know that the distance from 0 to our first boundary is not the same as the class width of all of our bars, okay? So the distance from 0 to our first boundary here is 0.5, obviously, but the width of our first bar is actually 50. So when we are doing that, we want to make sure that we set everybody up for the fact that we're not starting at 0, okay? And then the vertical axis, we're just going to scale as high up as we need to cover all of our frequencies. Our largest frequency was 11, so we want to go all the way up to 12, okay? And then we start placing our bars. So 9 people send between 1 and 50 text messages. So 9 people are going to fall in this first class, right? And then in the next one, 11 people fall in the next interval. And so while 11 people fall in the interval of 51 to 100, we're going to place it in the bar that represents 50.5 to 100.5 just so our bars can be together, and so on and so forth, right? So there's 4 people in the next one, 3, and then 3, and then 1, and then there is 0, so there is going to be a gap, but that gap represents 0 people sending text messages in that interval. Okay, and there you go. There's your histogram. Okay, and then, so we can create a histogram, a frequency histogram. We can also create a relative frequency histogram. And the only difference between the two is that instead of letting the vertical axis be a count of frequencies, we just change it over to the percentages of relative frequencies. The histogram stays the same, right? All you're doing is taking your counts and dividing them by the total number of data points and just creating percentages out of it. Everything else stays exactly the same. So now our vertical axis, instead of going from 0 to 12, it goes from 0 to 0.35, because 0.35 covers us as far as our highest relative frequency. Okay? And there you go. There's how you create a histogram.